Hey Valley Middle, today we're going to be doing the Chapter 4 review. Alright, let's get started here. Find the factors for 28. When you find the factors, it's easiest, I think, to make a factor tree so you can eliminate all the possible factors for numbers. So we'll start off with 1 and, of course, 28, the number itself. Now you got to start asking yourself, will 2 go into 28? Well, 28 is even, so 2 will go in. 2 goes in there 14 times. Now, will 3 go into 28? Well, 3 doesn't go into 28. 2 plus 8 is 10. 3 doesn't go into 10, so 3 is not going to be a factor of 28. But 4 does go into 28. 4 goes in there 7 times. And let's see, does 5 go into 28? Well, no, it doesn't end in a 0 or a 5. And 6 does not go into 28. So you're back at 7, and you are done. So here are your factors for 28. The factor pairs for 50. Well, I make a factor tree for that as well, and that's how I establish the factor pairs. So I go with 1, and of course 50 goes in, and then 2 goes in there 25 times. And if you're not sure if a number goes in there, just take 50 and divide it by 2. 3 doesn't go into 50 because 5 plus 0 is 5. 3 doesn't go into 5. 6 does not go into it because 2 and 3 have to be factors if 6 is going to work. 4 doesn't go in there. 5 goes in there. We're getting closer. 5 goes in there 10 times. 11 doesn't go into 50. 11 goes into 55 and 44, but not 50. 12 goes into 48, so that doesn't work. 13 doesn't go in there. 14. We're already back here to 10, so we're good. 7, 8, and 9, they don't fit in either. So, all right. So here we've got our factor pairs. So our factor pairs are 1 and 50. They are 2 and 25. They are 5 and 10. So here are all your factor pairs. These are your factors in order from least to greatest. Slide that over so you can see those factor pairs just a little bit better. So pair of pants has 2 legs. Factor pair has 2 numbers. All right, the prime factorization of 24. Pick any 2 factors for 24. Pick a factor pair for 24. I like 6 and 4. And 6 times 4 is 24. But neither of these 2 numbers are prime. So let's break them down into primes. So 6, I can break that down into 2 times 3. And I can break 4 down into 2 times 2. Now at this point in time, all of these numbers are prime. We've got 2, 3, 2, and 2. Well, 2 and 3 are both prime. So we have to express our answer in exponents in 6th grade. So you just count them all up. For the 2's, we have 3 of them. So that's 2 to the 3rd times 3. And this makes sense because 2 to the 3rd is 8. 8 times 3 is 24. If you're not sure what 2 to the 3rd is, 2 times 2 is 4 times 2 is 8. All right, now we have to do the prime factorization of 248. And I'll be honest with you, I don't know what it is. Well, let's just figure this out together. All right, so we know that 248, seeing this 48 here, I'm thinking 4 is going to go in there. So, because 4 goes into 100. So let's just take the calculator and do 248 divided by 4. Okay, so it's 4 times 62. 4 times 62. And just because I'm not familiar with that, I'm just going to multiply that times 4 and make sure I entered that right. That's good. Okay, so I can break 4 down into 2 times 2. And 62 I can break down into 31 times 2. So let's just think about this now. 2 is prime. And 31, is there any numbers that go into 31? I think it's prime. Let me think about it. 1, 2 doesn't go in there. 3, 4, 5, no, 6, 7, 8, 9. No, I mean, 31 is a prime number. So what our answer here is it's 2 to the 3rd times 31. And you'll notice that I used a dot that time for multiplication just to get you used to the fact that we can use multiplication. We can use a times sign. We can use a dot. Occasionally they use an asterisk. A lot of times they use parentheses like this if they're next to each other. That means to multiply as well. You just slide that up so you can see what the parentheses look like. There we go. And we'll flip her down. All right, let's keep rolling here. We are doing the GCF of 24 and 32. The greatest shall be the least, I always say. So I take the smallest number and I just make a factor tree, 24. So I got 1 and 24. I got 2, I've got 12. I've got 3 goes in there 8 times. Oops, I made it too small. And I've got 4 goes in there 6 times, and 5 doesn't go in. We're back. So these are all of my, I'm starting to sound just a little bit like Sal Khan. These are all of my factors. So I start with the biggest one and say, does 24 go into 32? No, it doesn't share that factor. Does 12 go into 32? No, it doesn't share that factor. Does 8 go into 32? Yes, it does. So the greatest common or the greatest shared factor is 8. All right, so now we've got to do GCF of 36 and 72. So again, I'll make a factor tree for the greatest shall be the least. So I make the factor tree for the least number, or 36. So I got 1 and I got 36. I've got 2 and I've got 18. 3 goes in there. 3 goes in there 12 times. 4 goes in there 9 times. Wow, I blew this one too. 5 doesn't go in there, but 6 goes in there 6 times. So again, I've got all of my factors here for 36. When I think about it, you got to start at the bottom and start asking these questions, going, from the largest to the smallest. Does 36 go into 72? Yes, it actually does. 36 times 2 is 72. So 36 is our greatest common factor. All right, so now we have to reduce these fractions into simplest form. So 35 and 42. I like rewriting these 35 and 42 like this. Looks like we can divide both of these by 7. So whatever I do to the top, I do to the bottom. 35 divided by 7 is 5. 42 divided by 7 is 6. This looks like, whoops. Yep, 5/6. Very good. Just going backwards to double check my answer. 5 times 7 is 35. 6 times 7 is 42. We are good to go. 18 and 36. All right. I'm not sure where to start with this one. I know 9 goes into both, so I'm going to divide both by 9. 18 divided by 9 is 2. 36 divided by 9 is 4. And I get a very familiar fraction here, which I can divide both of these by 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. So I've got 1/2 there. All right, let's get on to 4.5a. Write fractions as decimals. 5 divided by 8. Well, if you put that into the calculator, I'll just do this first one for you here. Make sure I'm still on the screen. Sorry about that, folks. Looks like I got to slide things up a little bit to get to the bottom half. All right, pop the calculator in, and fractions to decimals are so easy. 5 divided by 8. That equals 0.625. 0.625 fraction to decimal. Good. And then, I'm sorry about that word. It shouldn't be there. It shouldn't say reduce. 7 divided by 16. That is 0.4375. There's my decimal. Again, with 7/16 a fraction as a decimal. All right, write mixed numbers as decimals. Well, let's just take and set the 2 off, because we know we're going to have 2 wholes. And again, we'll just do 3 divided by 16. 3 divided by 16. That's 0.1875. So here's my answer. 2.1875. Here's the 2. Here's the 3/16. Mixed numbers as decimals. Okay, let's do this one here. Set the 4 off, because we know we're going to have 4. And let's do 4 divided by 5. We get 0.8. 4.8. There's my answer. Here's my 4. Here's my 4/5. All right. I can write decimals as fractions. Okay, so we've got 0.6. It's a decimal. Put your finger on that, or put your pen on that decimal. Make it into a fraction power. Put a 0 under each digit. Put a 1 in front of the whole thing. We've got 6/10. You divide these both by 2. 6 divided by 2 is 3. 10 divided by 2 is 5. 3/5 is our answer. Ooh, here is a nasty one. 10.03. Well, we know we got 10, so we've got to just work with 0.03. So I'm going to take in that 0.03. I'll put my pen on the decimal, make it into a fraction bar. 0 under each digit. 1 in front of the whole mess. I've got 10 and 3/100ths, and that is in simplest form. 10 and 3/100ths. All right. Let's see. I got 2 questions here. I think I can squeeze them in. And I have 3 pairs of tennis shoes for every 2 pairs of dress shoes that I own. What is the percentage of my shoe collection is dress shoes? Let's think about this. 3 pairs of tennis shoes to 2 pairs of dress shoes. All right, so 3 pairs to 2 pairs. It's a ratio. What percentage of my shoe collection is dress shoes? Well, I really have 2 out of the 5 pairs total. So if you take and pop that into your calculator, 2 divided by 5 is going to give you 0.4. So I've got 0.40, and I can make that into a percentage by moving that decimal 2 places. That is 40%. All right, write fractions as percentages. If I put 7 divided by 8 into a calculator, I'm going to get 0.785. So now I made the fraction into a decimal, and then I just move the decimal 2 places. What I'm doing is multiplying by 100, and I have 78.5%. For this one, 14 divided by 20, well, I'm not sure what that is, but I can divide 14 divided by 20. I can divide both of these by 2. I can get down into 7/10. I know that 7/10 is 0.7, so when I move that decimal 2 places, I end up with 70%. All right, thank you. I'm just going to pause here for a second. I got to go do bus duty. Okay, I'm back. What? I see dead people. Yeah, I know you want that. I know you wanted it, so I saw it sort of in for you. Parents, don't pull your kids from a math class yet. All right, 36%. So now we're doing percentages as fractions. Well, let's think about 25%. Here's 25%. To make 25% a fraction, I can make it into a decimal first and get to 0.25. Then I can make that into a fraction bar, 0 under everything, and put a 1 in front of it. I got 25/100ths. And then I could divide by 25, and I could get it down to 1/4. So I can use that same process for any fraction, but we just like 25% because this is just a landmark fraction for us. All right, so 36%. So now I got 0.36. I made it into a decimal. Then I got 36/100ths. Let's see, I can divide those both by, let's just start by divide by 4. Divide by 4, divide by 4. 36 divided by 4 is 9. 100 divided by 4 is 25. And again, you can use your calculator to do this. I got 9/25 there. So 4%, anytime you see a single digit, things are going to get a little nutty. So I'm right over here. I got my 4%. So let's make that into a decimal. I'm going to move that 2 places. And this is where kids get mixed up. So now you've got 0.04. So when I make that into a decimal, if I make that into a fraction and make that fraction bar, I put a 0 under both digits and then put a 1 in front of it. So now I have 4/100ths. Well, I can divide by 4 again, both of these. 4 divided by 4 is 1. 100 divided by 4 is 25. So I get to 1/25. Sometimes kids get 4/10 and 2/5 out of that, but you got to remember, move the decimal, 0 under each digit, then a 1 in front. All right, percentages as decimals. So 43%. Well, let's think about this. Up on top, I just did like this. I just divided by 100. I moved that decimal 2 places. Let's think of 25% again. There's my decimal, 0.25. So we just go to the left or divide by 100. So this becomes 0.43. This one here, I'm going to do the same thing. I know it looks weird, but here's my 0.4. Move it 2 places to the left. I actually end up with 0.004. I know that's weird, but when you think about it, let's make it back to a percentage. Let's take 0.25. We go to the right, we multiply by 100, and we've got 25%. So when I move this a couple back, it would be at 0.4%. And it makes sense because it's not even a whole percent. It's not even a half of a percent. It's 0.4%. So it's 0.004. All right, 20 and 1/2%. We're going fractions to decimals here. So this is where I usually use my little heart thing. So I've got my 20% and I've got my 0.5%. Well, I can make 20 into a decimal, that's 0.20, and I got 1/2 into a decimal, it's 0.5. So when I put them together, it's 0.205. And there I can see my 20% and my 5%. 0.205, 20 and 1/2%. Okay, 32.25%, I'll do the same thing here. Here's my 32%. Here's my 1/4%, so I'll make this guy into a decimal, that's 0.32. Make 1/4 into a decimal, that's 0.25. Put them together, 0.3225. Here's my 32%, here's my 1/4%. And that's a very lame looking heart. All right, let's go here now. Decimals as percentages. So again, let's say 0.25. It's a decimal for a quarter. I can make that into percent by just moving the decimal 2 places. So that's what I'm going to do here. We have 35%. We got 0.455. Sorry about that. I had my walkie-talkie on. So we have 0.455. So again, I moved it 2 places for 25%. I'm going to do the same thing here. 45.5%. Makes sense. 45.5%. All right, least common multiple. The least shall be the greatest. So I'm going to choose the greatest number, and I'm going to skip count by it. 12, 24, 36, and 48. I usually do 4 or 5 digits, and then I'll just slide that up a little bit. Get the rest of this on here. All right, then I say, does 8 go into 12? It does not. Does 8 go into 24? It does. There's my least common multiple. I mean, literally what it means, it's the smallest number that when you skip count by both 8 and 12, that you'll land, both 8 will land on 24 and 12 will land on 24. So multiples, you want to think skip counting. Okay, 16 and 5, so the least shall be the greatest, so I choose the greatest number. 16, 32, 48, 64, 80. Stop there. Now, does 5 go into 16? It does not. It doesn't go in here. You know it's going to have to end in a 5 or a 0. We've got right there. All right, now let's just say that you're not positive. You think, well, how do I check my work on a problem like this? Well, pretty easy. Just take and try 80 divided by 16. Yep, I skip counted right. And you can also do 80 divided by 5. Wow, that's a factor pair, 5 and 16. All right, very good. All right, compare rational numbers with inequality symbols. These ones here, you just have to take and put everything in order from, you have to make everything into a decimal. So you got 43%. So I'm going to make this into 0.43. And I got 3/5. So if I put 3/5 into a calculator, they're going to give me 0.6 as a decimal. Well, it looks like this one is bigger because there's 2 digits, but I can add a 0 on here. That's not going to change anything. And then I can clearly see that 0.6 gets 2 points. I heard somebody tell me this. They get 2 points because they're bigger, and the smaller number only gets 1 point. I thought that was kind of interesting. I just think this is the bigger side, this is the bigger number. This is the smaller side, there's the smaller number. All right, 0.43 is less than 0.60, or 43% is less than 3/5. All right, this guy already is a decimal, 0.04. 1%, oh boy, let's think about this. Let's go down here, let's think about 25%. Make that into a decimal, we move it 2 places, right, to 0.25. Well, let's do the same thing with 1%. So here's 1%, 1, 2, it's 0.01. So this to me looks like about 4 cents, and this looks like 1 cent. This one would be bigger. This one would get 2 points in the game. This guy just gets 1 point. Wish I could remember who told me that. That's pretty good. Alrighty. Alright. Last one. Now we've got to order rational numbers. This is nobody's idea of a party, but we still have to do it. So the way you do this is first we're going to make these all into decimals. I'm going to slide that over so you can see what I'm writing here. Make them all into decimals, then we can compare them. Then we're going to order them. And once we've ordered them, we're going to put them, we're going to give them back their original names. I'll just put orig names. All right, can't quite see that. Slide it up a little bit more. Give them the original names. All right, so make them all into decimals. Well, this is me 0.45. This stays 0.4. I'm going to add a 0 on there since I have 2 digits here. 3/5, 3 divided by 5. I just did that up here, right up above us. That's 0.6. So that's 0.6. And I'll give that an extra 0 too. And then 9 divided by 16. I don't know that one. Let's just see. 9 divided by 16. That's 0.5625. So 0.5625. All right. We're going from least to greatest. So here's my 1, 2, 3, 4. There are 4 numbers and 4 lines. Least to greatest. So these are going to be the big over here, and this is going to be the small. Well, let's think about money. We got 45 cents, we got 40 cents, 60 cents, and 56 cents, and some extra. Well, 40 cents looks to be the smallest, so it'll be 0.40. And then 45 cents, 0.45. And then 0.60. And then 0.5625, and then 0.60. Let me double check. 40 cents, 45 cents, 56 cents, and 60 cents. Good. That's why I check my work. All right, so now we've got to give them their original names. Well, originally 0.4 was just 0.4. So 0.4 is the smallest. And then this one here, 0.45, originally that was 45%, so I'm going to call that 45%. And then we've got 0.5625, so originally that was 9/16, so here's my 9/16. And then 3/5 was 0.6, so 3/5. So here is my answer. Let me double check. Least to greatest, smallest to biggest. Sweet! All right, thanks for listening. Have a great day.